Good evening, students. I'll start with the class. In the previous class, we were solving problems based on friction. So I'll continue with that. An object of mass m is moving with velocity v naught. Find the time after which it stops. And also calculate displacement. An object of mass m is moving with a velocity v naught. So it's like you're having a block which is already moving. So it is in motion with velocity v naught. Obviously, if the block is in motion, okay, if it is moving, so while in moving, which friction will come into picture? Kinetic friction. So here, what we'll have to do? We'll have to use kinetic friction, right? Body is in motion. So therefore, kinetic friction will be used. So what will be the formula? So that will be f of k will be mu into n. So this will be k. Now what has happened? Find a time after which it stops has been told. So this is in motion. So after certain time, this will come at rest, means it will stop. So at rest, definitely the velocity will be 0. So now what we'll do, we'll just try to draw a diagram for this one. This would be having a force downwards. There's a normal reaction which is upward. This is your mass. This side is the body moving. So this side is your applied for this motion. So definitely your friction will be on the opposite side. Kinetic friction will come this side. So what do we have to calculate? Time. So for time, we know this formula, kinematic equation, mu is equal to what all has been given. My initial velocity is given, final velocity I know, and this is time. So I can use this formula. So which is my initial velocity now? Initial velocity means when the body is moving. So right now it is moving with initial velocity. So u is how much? Given to me as v naught. Final velocity v will be 0. Now v we know, u we know. What is acceleration? We know that force is mass into acceleration. So what will be acceleration? F upon m. Okay, we have to calculate time. We know what is v, we know what is u, we don't know what is a. So for that I'm trying to find out. Okay, so we know force is mass into acceleration, so m will come down. So what will be F? That is nothing but your this thing, frictional force. Because this side there is no applied force, there is no more extra force which has been applied. So the only force which is there over here is F of k. Okay, so this will be straight away instead of F. So that will be, you can consider it as F net. So there is no other force. So this side it would be like 0. So this will be acceleration. We have to take always negative. I'll tell you also why negative. I had even given a statement. If the applied force on a block is removed, why negative I'm explaining, then always it will be negative. Take acceleration as negative. If you want to know how it is coming, you can see this. Right now there is no applied force, so this force will be 0. When can an object will stop? Okay, this object will stop only if the external force is removed. So the only force which is there is frictional force. So F net is always what? It would come as 0 minus Fk. So you can write, if you want, one more step here at this side. So this fellow is in the opposite direction. How is to solve earlier? If this was 12 and this was 8, we used to solve it as 12 minus 8. That was F net, because they were in opposite direction. But now this applied force is missing, so that has been removed. So straight away what it will be? So 0 minus F of k. So that is how you get this as negative. The Fk is nothing but mu k into n. Now n, we can check over here what is the value of n. N is same as mg. N is equals to mg. From this diagram we can see. So this equation will become, m and m will cancel. The acceleration is nothing but, I got the value of acceleration. Now we'll use that formula and now substitute. We have to calculate time, no? So v was what? 0. U was how much? Given to me as v naught. Acceleration is how much? This is your time. So time value V naught you bring this side, minus and minus will cancel. Now only time I want to calculate, so keep T here. So this is multiplication, so everything will come down. So your final answer is mu K into G. This is your time. Suppose values were given, you have to substitute the values. Suppose if it was said it is moving at a velocity of 30 meters per second and then comes to a stop, so this answer would have been 30. And coefficient of friction, suppose if it was given as 0.03 or something, then you have to substitute. So same problem, if given with the values also, you can solve in a similar way. One more thing is asked is to calculate the displacement. Displacement means we have to calculate the value of S. So you can use another kinematic equation. V is 0, we know that. U is how much? V naught square. A we just now found out. So bring this fellow this side. So it will become minus V naught. Minus minus will cancel. I want to calculate the value of S, so this whole thing will come down. That is your answer for displacement. Next question. This is a bit applicative type. The question comes like this. Which is easier, push or pull, when a force is at an angle? Okay, if there's a block and you're applying the force at some particular angle, maybe at 30° and all, which becomes easier, to push the object or to pull the object? So there are two cases. First we'll see in case of pulling. So you can apply at any angle. Suppose I'm trying to pull this at some angle. Pulling means what? Obviously the arrow will be in this direction. Pushing would be, later I'll draw after this. Pushing, the arrow would have been this side. Like I'm trying to push. Or this side, like this arrow. If I want to push this object. Now I want to pull this object. So obviously arrows will be going outwards. So this is the applied force outside. So this is for the pull. Must be some M. Now I'll write all the possibilities, which all forces will be there. One will be your mg. This side would be your N. Okay, the surface. Now, obviously, if this is at an angle, okay, so what is going to happen? It will have components. Okay, in this diagram we'll draw, otherwise you will not understand what was the question given. So one, if this is your theta, this will be a f cos theta, this will be a f sin theta. Now equate. Vertical forces are always this, and what will be there? Always a frictional force will be there. So we will not bother to know whether it is static or kinetic. There will be some frictional force. Okay, we just want to know whether push or pull is easier. That's it. They never said whether it is in motion, whether it is this. So we'll just keep it as F, frictional force. So now the two equations which we'll get, first equate this opposite forces. So this will be what? These are both in the same direction. So N, two vertical forces are this. N plus F sine theta will be equals to mg. So what is your normal? Take it on the other side. These are equating the vertical force. This is for vertical. Now we'll check whether what is the friction for this particular case. Okay. So what is the formula for friction? Mu into K. Basically, I want to know in which case there is more friction, whether in push or whether in pull. This will be N. This is the frictional force formula, mu into N. So just substitute it here. So N value what we got? F is equals to mu into mg minus F sin theta. So I calculated friction for the pull. So just keep it this much only. Now we'll check what is the friction for push. So for push, the diagram will look like this. So we write all these components. So this will be at an angle theta. So obviously we will have two components. This will be F. So all directions will be this side, coming towards him. This will be F cos theta. This would be F sin theta. The normal force, that is N. And this will be your M. And your frictional force will be this. So if you want, you can still modify the diagram and simplify it. So there is one vertical force. There is one vertical force. But look at the arrow here this side. So this force arrow is this side now. So F sin theta. This is your N. This is your mg. This is your F cos theta. And this is your friction. Now equate the vertical forces. So what is happening? They are in the opposite directions. So what will happen? This will be what? N minus F sine theta equals to mg. N is positive in this direction, so it is coming in the opposite direction, so this will be minus. In the previous case, no, both were going upward, so both were positive. But now upwards, only one is going, so that only will be positive. This one is coming downward, so that's why it will be minus. So this 2 is equals to this. So what will be the value of N? Mg plus F sine theta. So now use the same way previous. We'll calculate what is friction. Mu into N. The friction will be mu into mg plus F sine theta. So this is the friction for the pull, and this is the friction for push. Pull friction, and this is push friction. Now looking at the formula itself, we have to check which one has more friction. Obviously, looking at this, if you are minusing some answers, it will be less. If adding two answers, obviously it will be more. Consider if this was 10 and this was 15. Okay, one was 15, the other one was 10. 15 plus 10 would always give you 25. The same thing, 15 minus, okay, 20 would give you ulta. So here the friction will reduce. Here the friction is increasing. So which has more friction? Looking, comparing, definitely the push is having more friction. We can write push has more friction than pull. So more the friction means what? More friction means more opposition. More the friction means it will more try to oppose more. So you have to put extra efforts. More opposition means extra efforts to overcome it. So definitely pushing will become difficult. So therefore pull is easier. When this is at an angle. You can think only of this. If you have a toy, okay, and if you have a string attached to it, definitely no child will try to push it from the string at an angle. Always you try to pull the toy. Okay, so pulling always becomes easier. If you go to push, it will not move ahead as freely as if you try to pull it. So you can remember that toy example only. So if you have a toy and if you have a string attached to it, okay, so you can always pull it. So pulling will be easier compared to pushing. Next question. A body of mass 4 kg is there, is moved using 10 Newton. Calculate coefficient of kinetic friction. The mass has been given, applied force has been given, and mu of k has been asked. So we know the formula. Mu k into n. So now what is the diagram looking like? This is 4 kg suppose. This is mg. This is n. This is mg. This side is F, applied force, which is 10 Newton, and your frictional force will be ulta. So calculate what is the N. Okay, so this is your main force, main formula. Now, as per this, look at the oppositings are always equal. So from the diagram, we know that N is equals to mg. So N will be how much? 4 into 10, so it will be 40. And these two are opposite and equal. So Fk is equals to F, which is equals to 10 Newton. So just substitute here. So Fk is mu k into n. So this we got as 10, this we got as 40. So 0.25 will be your kinetic coefficient of kinetic friction means mu of k. Next, there are some derivations. First one is, suppose the topic is we have a vehicle on a leveled circular road. Leveled leveled circular road means suppose if there's a circle, okay, or not necessary, or it could be a sharp turn also. Okay, suppose if you have a road like this. We'll draw it little big so that the diagram also fits in. Wait. Okay, consider it's a big circular road like this and a leveled one. Leveled means it's a flat here. It's not like this part of this road is high and this part is low. It's a proper level. Okay, so the this derivation what we will be doing is to calculate maximum velocity of the vehicle to stay on the road. Now, suddenly you're moving and then there's a sharp turn. Imagine you just try to keep your speed increasing. Okay, on a turn, we never try to increase the speed to such an extent. Okay, so what will happen? If you keep on increasing the speed, you will go out of the road. Okay, so you have to maintain maximum velocity in such a way that even if you may till the edge at least you can go, okay, of the road. But if you cross a certain amount of velocity, if your speed increases beyond a certain limit, your vehicle will not stay on the road, it will go out of the turn, okay, and will fall in whatever at the side. So how much should be the velocity? We have to derive it. So this derivation is to calculate the maximum velocity for the vehicle so that it remains on the road and does not fall out of the road. So consider this is the car, wheels will be there, no? Okay. So you can just randomly draw. So there will be two wheels. Okay, the car is in the front part. So actually it would look like this. Not the tire like this, it would be vertical like the car is coming in front. So if this is the front pane, okay, so this would be the driver. So vehicle is moving this side. So it becomes difficult to show it in a 2D diagram. So imagine that the car is coming this side. There's some back car is there, the part of the this. So this is the front part of the car and it is coming in front. And definitely there will be, now we'll keep a reference point for this. This may be the center of the car. So from here, definitely there will be a force that will be mg for the vehicle. Now reactions will be what? Now which all two things are touching the surface? This car is not touching the surface. See, only the tires are touching the road. So when will a normal reaction comes up? Only when the object is touching a surface. So at which 2 points the object is touching the surface? At the two tires. So here there will be one normal reaction upward and this will be normal reaction upwards. Okay, so what we'll do, we'll write in general, like if you add these two, so this will give you, will directly add this combination and write it as n1 plus n2. So this tire is touching the surface, so one normal reaction will be here. This, for this tire there will be another normal reaction. Now obviously the tires are touching the ground and they are trying to move, so there will be friction. So this one will also have one friction, so we can consider it as F1, and for tire 2 we'll consider as F2. And now this is a circle. So we have to consider some radius r also from this point. If this is the center of this circle, okay, then this might be r. Okay, this is for friction, this arrow is for friction, and this is for the r. This much distance would be r from here to the center of the car. So we'll write all of this. Consider vehicle of mass m. So the vehicle has mass m kg going around a level circular road of radius r with constant speed. Suppose if the speed is v. Let n1 and n2 be the normal for the inner and outer wheels. So this will be like the inner wheel and this would be like the outer wheel. Which way they are acting? Vertically upwards. Which act vertically upward. Therefore, total normal reaction will be how much? Both are in the same direction. Even if you don't draw this arrow, no, it's understood, okay? No problem. It's like just a combination of these two, N1 plus N2. Even if you are calculating, now see, equate the vertical forces. Which all vertical forces are there? This and this. So basically, it's nothing but mg will be nothing but equals to N1 plus N2. So if you are taking this, no, don't take all the three, N1 and N2, or straight away N1 plus N2. Either you take this main arrow or these two arrows. In both the cases, it means the same. Even if you don't write this, no, it's fine. Because, but only thing you have to make sure that mg vertical force is equals to addition of both of these two forces, because they are both going in the same direction. So this will be our equation 1. So this is equating the vertical forces. Now we'll describe this. Let F1 and F2 be forces of friction for inner and outer wheel. Which are acting towards center of the circle. So therefore, total F will be how much? Total friction will be F1 plus F2, because both of them are in the same direction. So you know what is the formula for this? F is nothing but mu into K. Mu into N, sir. Same way, F2 will be what? Mu into N2. Why? For this tire, it is N1, and for this tire, it is N2. Coefficient of friction will remain the same, because why? Material of the tire is same. You don't use different types of wheels, okay? Both the wheels will have same type of material, so same friction for both of them. This N1 is for this friction, this N2 is for this friction. So total, just substitute here, total will be how much? Mu N1 plus mu N2. Mu you can take out common. So you can mark this as equation 2. So what is the value of N1 plus M2? N2 from equation 1. From equation 1, we know that N1 plus N2 is equals to mg. So put it here. Put in equation 2. Put the value of N1 plus N2 from equation 1 in equation 2. So instead of N1 plus N2, what will come? Mu into mg. So write this as equation 3. Now this is all about friction, but what are we talking about? Velocity. Okay, so velocity, now this is for circular, now it's not a straight line. Okay, we are not doing motion in a straight line now, where it will be normal, that formula v is equal to u plus at, that will not come into picture. That is only because it's for straight lines. Now for circular, we had studied something called as a centripetal force. Okay, for circular, we don't call it as normal force, we call it as centripetal force. The centripetal force of the vehicle will be F will be equals to centripetal force, you can write it as Fc, mv square upon r. So this formula we already know from the previous chapter. Okay, that is centripetal force for any vehicle moving in a circular path is this. So where v is the velocity of car or the vehicle and r is the radius, m is the mass. Don't put it in a box, okay, and just put this and put it as equation 4. Now what do I want to calculate? I want to calculate v. Before that, now what is the main concern? We have to make sure that the vehicle does not go out of the road. The vehicle has to remain on the road. When can it remain on the road? Only when the friction, what? It's like how the car is trying to move out of the road, but now these tires have to block it. Okay, here this tire and the road, there should be some friction between them. It has to try to oppose, okay, try to stop the vehicle from going out of the road. So when can it happen? This force must be more than this one. Okay, the force from the tires to stop it must become more than the force of the car, because if car is putting more force on the from compared to the tires, it will go out. But now if the tires are having more friction, they will try to stop it, so it will not go this side, rather than it will have little control, it will try to stop the car, means reduce the speed of the car, this friction. So this friction has to be more than this normal centripetal force, otherwise it will go out of track. So the main condition is for the vehicle to stay on the road, the force of friction must be either equal to or more than that, or greater than. So Fc or F should be, you can say, basically it is, you can say Fc should be less than a frictional force. You can read the other way around also. This means what? Centripetal force should be smaller than or equal to the force of friction. Either you can write like this, or F is greater than equals to Fc. Both mean the same. So now what is Fc? mv square upon r, and this is F is given in equation number 3, and this is from equation 4. So basically what we have to calculate? Velocity. Take rest of the things on the other side. So v square will keep here only, r will go up, and this m will come down. So m and m will cancel. So v square should be less than equals to mu g and r, and v will be less than equals to square. If you take it on this other side, it will become root. So this is very important. The minimum velocity, or sorry, the maximum velocity, because it has to be less than this. So if suppose maximum velocity at certain point is some 50 kilometers per hour, the moment you cross 50 or 51, your car will go out of the road. So it has to be less. So 49, 48, 46, 47, anything can be okay. So your maximum can be 50. And then if, so what is, how to read? Your V max, whatever has to be less than this particular value. So it is based on your friction, gravity, and the radius. How much friction is there between the wheels? Okay, gravity. Imagine your tires were very smooth. It had no friction. Okay, then it would, the car would slip and go out of the road. So this is for the derivation for maximum velocity for the car to stay on the road. Next one is, one more derivation is there. Curved road, or also called as banked roads. So what does this mean? In the previous this we had seen that it is a level road. So I just share with you a slide which will actually show you the 3D part. Otherwise it becomes difficult to explain how it must be looking. This is photo. Wait, I did not get downloaded, I think. One second. For car racing and all, you all must have seen little bit of slope is there on the road on one side. Just check in the download. You know? Just take a screenshot quickly and send you that only.
Miss, this is the last part.
Yeah, yeah. One sec. Yeah. This is a banked road, not a leveled one. See, towards the end, especially in car racing or cycle racing, you must have seen. Okay, slightly on the one side it is sloped. Banked means at an angle. Okay, it's not a. In the previous case, the level was 0, so it was at a 0 degree. But now this will be having some angle. So actually, when you try to draw the diagram for a banked road, you have to draw this. I'll show you. See, like this. Okay, so that angle theta will be there. So this is how you have to, in a 3D it becomes difficult to draw diagrams. So you can imagine the car actually looks like this. So now what is happening, in the previous proof we had drawn that line flat. of the tire, but now one tire is upwards and one is this side. It's at an angle. So we'll check what is the velocity for this case and what is how to calculate that banking angle. So first part is to calculate the banking angle. How to draw the diagram? You can just draw it like this. This is at theta. The car will be like this. The car is actually coming this side. So the driver would be here. This would be the front part. It looks like as if it's going this side, but you just have to remember it's coming this side, outer side. So now you can draw the road like this. So which all forces will be there? You can check. Now this is at an angle. So this will be respective at a straight line. This will be mg, straight. Now this normal will definitely be at an angle because it is always drawn perpendicular to the surface. It will not come like this because which is the surface reference line like this. So the angle will be like this. Straight means perpendicular to the roof of the car, like. So this would be what? N1 for tire 1, and this would be like N2. This would be F1. This would be we'll write this. So what does a banking road mean? So can write what does this banking of curved road mean? The system of raising. Raising means keeping one higher. Raising the outer edge of a curved road above its inner edge. Means what? The outer side is slightly higher compared to the inner side. So this part will be higher and this would be slightly lower. Okay, and then you can add on the angle through which the outer edge or you can directly make it shortcut, and the angle of banked road is called angle of banking. So we are deriving the formula for angle of banking. So what we'll do, we will simplify this diagram. Okay, so we will not draw a car, instead we'll just draw a box. So what all are there? One is this mg. Now what I'll do, I'll consider that main n. So n will be n1 plus n2. We already know that. And f is how much? f1 plus f2. So I'll directly write one main arrow only. So this will be your n, this will be your f. We can write then, consider a vehicle, same thing like previous only, of mass m and moving with constant velocity v along a banked road at an angle theta. Let r be radius of the curve or the circle, whichever. So this is the diagram. So obviously looking at this, what is happening? This is not a straight line, it is at an angle. It's not vertical straight. See, with reference to this, this would be at some angle. With a reference to a straight line. So what we'll do, we will resolve n into two components. So obviously it will have vertical as well as horizontal component. In the next diagram you draw, okay? Yeah, one more time we'll draw. So this will be like this. So obviously with reference to this is anyways your mg. So this is your theta. So this is your vertical component of n, and this is your horizontal component. So this will be n cos theta. This would be n sin theta. It's a straight line, huh? Look properly straight. So that is r cos theta is vertical and r sin theta is horizontal component. So these are the two components. And there will be always a centripetal force. Okay, centripetal force is Fc on the other side. Now look at this diagram. Now the moment you resolve this will not come into picture because n I already splitted it into two parts. So we don't have to look at the angle one. Okay, we have to just look at properly vertical and properly horizontal forces and try to equate. So obviously which two are equal? The vertical one is equal to this one. So we know that n cos theta is equals to mg. So that will be our first equation. That is comparing the vertical one, vertical forces. And comparing the horizontal forces, what we will get? R n sin theta will be equals to Fc. So what is Fc? Nothing but your centripetal. That formula is the mv square upon r. Put it as equation 2.
Teacher, can you explain the diagram again?
Yeah. Now this part you have understood. This is n. Normal will be directly perpendicular to this of the car, of the surface, because it has to be perpendicular to the surface. This mg is irrespective whichever it doesn't look at the angle. This is always with reference to your main thing, straight vertically downwards. Now if the car was like this straight, then this would have been what, n, and this would have been a mg, because this is anyways perpendicular to this surface, but now it is at an angle. So you have to draw it perpendicular to this fellow, to the surface. So now where is the surface of the car? Here, like this. So that's why it became at an angle. We cannot compare anything opposite like this. This equals to this. So we have to, any vector which is at an angle, we have to resolve it into two components. So that will
Okay,
be
teacher. Okay.
resolved, and then this will be gone. And this centripetal force will be always like this, straight from the center of the curve, like this. So it will be, this is the radius, so it would come like. Now equating this will be equal to this. So we got centripetal force, we just wrote here. Now what we'll do is we'll divide equation 2 by equation 1. Divide equation 2 by equation 1. N sin theta upon n cos theta, this upon this. N and n will cancel. If nothing is there, it means like having 1. So make it ulta. Sin theta upon cos theta will be tan theta. mv square upon r, this will be 1 upon mg. M and m will cancel. So your angle is, this is the banking angle. Next one, we have to calculate the velocity for the same thing. This is going to stay on a banked road. Now only thing is what will come into picture is the frictions when it is moving. Okay. Same diagram again we have to draw. So starting part you write the same thing. Consider, no? Consider a mass m of this vehicle with velocity v moving at an angle theta, let r with the radius of the curve. Okay, so that starting part, consider part, you write the same. Now we'll draw the diagram. So this is straight away mg. This is your n. This side was your what? Centripetal force. Now, which side will be the this? This is a frictional force. So right here and keep this is frictional force. This was straight up, no, like this. How we had drawn the previous one. Okay, just write only this much and keep. Don't write FC. Okay, just write this. Yeah, correct it. So now we will just try to resolve this. So resolve R into two component. Sorry, you can say N. Two component. Same previous type only. So one will be vertical, one will be N sin theta. Horizontal would be N cos theta. So I draw the diagram again. So now just see, without a box I'm trying to draw. Suppose if this was a mg, this was a n. So I will resolve it into two components. One is this was theta, would be n cos theta. This was n sin theta. Now there's a frictional force also. This was a centripetal force. Same previous diagram only. Now only thing what will add on is, okay, this was FC, exactly opposite to your n sin theta. And now who is there? This is a frictional force. Now this is also at an angle. So this angle will be theta. So resolve it, this F also into two parts. So after this diagram, you write resolve F into two components. Why? Because this is also at an angle. N was at an angle, so I resolved it into two components. So now this is not into picture. Now F also is at an angle, so 2. So which is a horizontal component? Horizontal will be, again, see already there's one of this fellow, one more will come into picture. You just add on there only, on the same line, the horizontal. So F cos theta. And this will be, vertical will be F sin theta. For this F, this is the horizontal component, this is the vertical component. Two horizontals will come, one of N and one of F. The horizontal is F cos theta and vertical is F sin theta. This is downward. Why? Because the arrow is coming this side. So it would be here. Here the arrow was going up. So that's why this was this side. So now let us apply, equate this vertical forces. This and this is not to be considered because we have already resolved the main F into two components. So which are the vertical forces now? This and this. Oh, here also is there, no? Mg is also there. So which all are the vertical forces? 1, 2, 3. So n cos theta will be equals to F sin theta plus your mg. This mg was already there from before only by default. This F sin theta came because of this one's vertical component. Okay, so what will be mg? You can just bring it this side. N cos theta minus F sin theta will be equals to mg. You can mark this as equation 1. This is where we equated our vertical forces. Now we see our horizontal forces. So which all are there? This two and this one. So this plus this n sin theta plus F cos theta is equals to F, this capital. That is not what a frictional force. So you can just substitute centripetal force, that is mv square upon r. So mark this as equation 2. Now what we will do is we will divide equation 1 by equation 2. So first divide by second. N cos theta minus F sin theta upon N sin theta wait, I want this on top. 1 second now. 2 by 1 we'll have to do. Mv square upon r I want on top. Okay, so we do equation 2 by 1. Just write equation 2 by 1. Otherwise this will go down. This I want here, this on top. So 2 divided by 1. N sin theta plus F cos theta upon N cos theta minus F sin. So if nothing is there, it means it is 1. So now reverse this. M and M will cancel. Now what we'll do is this will try to substitute. Friction, we know that is always mu into N. So instead of F, I'll put it as mu N. What is common? N is common everywhere. So take out N common. and n will cancel. So I'll try to simplify this. In terms of banking angle is what? In terms of tan theta. So I want to try to make this tan theta. Fine, I want to make it 10. So what I'll do, I'll have to directly, I cannot separate these terms because there's a plus sign here, there's minus. I cannot do sin theta upon cos theta straight away like this and this upon this. If they were both multiplication, then I could do. But now I want to make this as tan theta. So what I'll do, I'll have to divide it by cos. So if I'm dividing the numerator, obviously I have to divide the denominator also. So what I'll do is divide numerator and denominator by cos theta. Why? Because I want to make it in terms of tan theta. Everything will get divided by cos. All the terms will have to divide by cos. So what will happen? This will cancel. So sin upon cos will give you 10. Is equals to v square upon r. Our aim is to find maximum velocity. So maximum velocity we have to calculate, then take rg this side. It's in the denominator, it will go up. And then v is nothing but root. So that's the final answer. So we're done with all the derivations. This one small problem based on this banking angle. Question is, an aircraft executes a horizontal loop at speed 720 km per hour with its wings banked at 15 degrees. What is the radius of the loop? So obviously the moment your rate is banked at 15 degree, it means your banking angle has been given, that is theta. Theta is 15 degree. Speed, that is v, is given to you 720. Now what is r? So the moment anything related to banking thing comes, you know that your banking angle is given to me. This formula we have already derived just now. Tan theta is v square upon r. So 10 or 15 degree. Now, kilometers per hour. You have to convert it into meters per second. Standard one. So V is 720 kilometers per hour. I want it in meters per second. So 1 kilometer, it is 1000 meters. And 1 hour is how much? 60 into 60. So that will become 200 meters per second. Radius we have to calculate. Gravity we can take as 10 or 9.8. So what will happen? 10, 15 is coming out to be around 0.26. So 200 square, you can write it as 200 into 200 two times. So 1 0 will cancel. R you bring here, this fellow will go down. And then calculate your value.
This how we are getting that 0.26.
10 or 15 degree from log table you can directly check. Or you can do it on the calculator.
Okay, miss.
Directly use your log table and do 0.26 you will get. That difference is there. This is what 10, 15 I am finding. And arc 10 means that will be 10 inverse. That ulta we have to do. Suppose if we have to find theta and 10 inverse of something 0 point something, that is different. That comes in decimal points of 1 point. That this big number that will never come. That 0.26 you can take two zeros up. So this will become 200 into 20 into 100 upon 26. And then you can calculate. Anytime you remove decimal points, you can add zeros on numerator. This is enough. 10 to find maximum speed with a car with which a car can safely travel along a curve of radius 70 meters if coefficient of friction between wheels and road is 0.3. Okay, so we have to calculate V maximum. Radius is 70 given to me. Mu is given to me as 0.3. G we can take as 10 or 9.8. And now already formula you know for V max. That is 0.3. Radius is 70. And this is 10. So this will be 3 into 7 into 10. 21 to 210. Around 14.4. Velocity will be meters per second. So this has to be maximum. So whichever is your velocity should be less than or equal to 14.4. But they have asked maximum speed. So directly only you can write it as equal to and right. Maximum can be 14.0. Okay, so with this I finish with the chapter. From Monday I'll start with new chapter. That will be work, energy and power. Just kidding. Okay.